Okay, so of course I can't be with you guys today, but I figured what I would do is make this video so that you guys get to hear my wonderful voice lecture to you while I'm in New York. So anyway, here we go. Just some real quick review before we go into the actual lesson. Of course, last week we talked about atoms and properties, and so I'm just going to quickly go over these slides with you. So if you missed them or just to review, because I know I've slept since we went over this stuff. I know you've slept since we went over that stuff. So let's just get into it. So first off, we talked about how matter is anything that has mass and volume. Remember, mass is the amount of stuff that's in something. Volume is how much stuff that stuff takes up. All right, how much space that stuff takes up. And then an element is made up of only one kind of atom. So examples would be carbon is one type of atom, so the element carbon is only made up of carbon atoms, or oxygen is only made up of oxygen atoms, and so on and so forth. All right. Next up is that atoms are the basic units of matter. So all matter is made up of atoms, and all atoms have a nucleus that contains protons and neutrons. And so here, let me move this out of the way for you. And there you can see that the atom showing the protons, neutrons, and the electrons. And then the nucleus of the atom is surrounded by electrons, and then we talked about the different charges that all those different things have. With neutrons having no charge or neutral, protons have a positive charge, and electrons have a negative charge. If an atom has more protons than electrons, then it is a positively charged atom, and if it has more electrons than protons, it is a negatively charged atom. So that's just some stuff to keep in mind. Moving right along, we talk about what happens when atoms get together. So that's when bonding takes place, chemical bonding, and we have a couple of things that can form. So first off, a molecule is formed when we have two or more atoms bonded together or bound together. All right, so examples of that would be oxygen. All right, oxygen is O2, so that's two oxygen molecules that have bonded together. A compound is a molecule. All right, so we've got a molecule here, but it has two different elements or two different atoms. Our example would be water, H2O. So H2O, water, has two hydrogen atoms and one oxygen atom. And since there's two different elements, it becomes a compound in addition to a molecule. Now, this text right here says, very important, that all compounds are molecules, but not all molecules are compounds. And the reason why is because molecules are just two or more atoms bonded together, but compounds have those different elements in there. Okay, let's move on to the next slide. All right, so this is our example. We got our oxygen molecule right here. As you can see, it's the same atom, all right, same element, so it's a molecule. We've got a water molecule, all right, so we've got more than two atoms put together, but they're different, so this molecule is also a compound. That's right, it is a compound. Okay, let's move on. Solutions. Solutions are not chemically bonded, all right? But their ingredients are usually evenly distributed. The examples we talked about in class were air, ocean water, Kool-Aid, Pepsi. And so if you think about those things, let's take Kool-Aid for example. You've got water, and then you put sugar in the water and stir it up so the sugar's all evenly distributed out. And then you add your Kool-Aid packet to it, and that's your flavoring and your color, and then you stir that up so that it's all the same. And then you get to enjoy some nice Kool-Aid. You know, like my favorite is grape. I love grape Kool-Aid and cherry Kool-Aid. I just like all of them, really. But anyway, so those are solutions. And I told you guys that how I was going to test you over this was I was going to have you identify solutions, compounds, elements, and molecules and determine what something was along those lines. All right? So let's move on to the next thing. We're going to talk about macromolecules. All right? So we've talked about smaller pieces. Now we're going to talk about the bigger pieces. These are organic compounds that form long chains of repeated molecules. All right? Some of these are called polymers. All right? And they're super important to animals, humans, stuff like that. And those are proteins, nucleic acids, lipids, and carbohydrates. All right? So let's talk about each one of those individually. So we've got proteins. These are polymers that serve many functions. such as building bones, skin, hair, and muscles. Yes, your hair is made of proteins. They act as hormones, and hormones are like your nervous system. They transmit signals, but instead of sending signals from one part of your body to your brain, all right, they may send a signal from your kidneys to your stomach, or from your kidneys to your pancreas, or from your thyroid to your stomach. And so they send those hormones travel throughout your body in the bloodstream, and they send signals from one organ to another. And then enzymes, what they do is they help chemical reactions take place. And how they do that is by attaching to whatever it is and then helping it split it apart. So the example I used in class was with lactose, lactose intolerant people. Lactose is a sugar that's in milk, dairy products, and if you're lactose intolerant, you lack the enzyme lactase, which helps break down lactose, and if you don't have lactase, you can't break down lactose, and then you get really sick when you take dairy products, and bad things happen. All right, and then the last thing we had to talk about was nucleic acids. And the main job of nucleic acids is to direct the production of proteins. And then DNA and RNA is made of nucleic acids. And so all those things go together to make what make up these macromolecules. All right, sorry about that. Somebody was knocking on the door, interrupting class, because class is going on right now. So, but anyway, all right, let's go back. Let's go on to the next slide. Lipids, okay? I forgot about this one. So anyway, so that wasn't the last one. This is the last one, I think. Is it or is it not? We'll just have to find out. All right, so lipids. These are the weird polymers. These are weird because they don't dissolve in water. Okay? The other polymers can dissolve in water. These don't. So examples of these are fats, oils, waxes, and steroids. All right? And these don't dissolve in water. And so they usually float on top of water. That's where we usually see them because they're less dense than water is. All right, let's move on. Let's talk about water. Water is unique because of the properties of it. Now, some of you, this may be a new slide. We didn't make it to this slide. Only some classes did, some didn't. All right, so some of you need to start taking notes. All right, so I'm going to give you a second to make sure everybody's on the right page, and then we'll continue taking notes. So the page that you need to be on is, all right, so this is page 7 in your workbook. So make sure you're on page 7. Let's get ready to take some notes. All right, so the unique properties of water. Okay, first off, really cool property of water is that water sticks to itself. All right, so if you've ever been like playing in the shower or something like that, and you get water droplets close enough together, then they stick to each other. All right, they'll come together. That's called cohesion. That is when water sticks to itself. It's attracted to itself. All right, that's also what makes the surface of the water. It's called surface tension or cohesion. And so that's what allows those little water spider things to walk across the water. All right, or to allow the bubble at the top of a glass. If you ever get a glass too full, it'll make a bubble on the top. That cohesion lets it stick together. All right, another important part or a property of water is that it resists temperature change. So water can absorb large amounts of energy. And that's a really, really good thing. All right, because then it can buffer the air temperature. So if the air is cooler, then energy from the water, heat from the water, will go into the air. And if the air is hotter and the water is cooler, then temperature from or heat from the air will go into the water. And so it kind of helps maintain temperature. However, like we're experiencing right now, hurricanes can pull that energy out of the water and make the hurricane stronger. So there's good things and bad things about that. But for the most part, water being able to resist temperature change is a good thing. The density of ice. So water is unique in the fact that it expands when it turns into a solid. When it expands, it becomes less dense. This makes it float. All right? And then finally, all right, water is a universal solvent, which means water can dissolve many other molecules, which means what it means by dissolve is break it apart. All right? It can dissolve or break apart many other molecules, which is really, really important whenever we're doing stuff. All right, that's the reason why we're made of water, is because water can dissolve, or a lot of things can go into water and then come out of water. It's really cool stuff. All right, so any questions about water? If you do, write them down. I'll answer them whenever I get back. Let's move on. Next slide. Okay, we're going to talk about acids, bases, and pH. So the pH of a solution tells how acidic, or here's a new word for you, alkaline. Alkaline is just another word for basic. So the pH of a solution tells how acidic or how alkaline a solution is. Acids will have a pH of less than 7, and bases, or alkalinity, have a pH of more than 7. Now, a common misconception is that if something is basic or alkaline, it's not as harmful as something that is acidic. And that's not entirely true, because bases can be just as harmful if it's a really strong base as a strong acid. All right, does anybody have any questions about this? Awesome. Okay, like I said earlier, if you do, jot them down, ask the substitute, they may know. All right, or else I will answer those whenever I get back. Let's see what the next slide brings us. Oh, wow, look at that. We're done with notes. I'm excited. How about you? Okay, so guess what it's time to do now? Now it is time to do our practice pages in the workbook. So I'm going to see what pages those are, and I'll be right back. Okay, so I've got my workbook here on the screen, so hopefully you got your workbook out because we were taking notes. And then what we need to do is go ahead and we're going to turn to page 17. 17. So there's 8, 10, 13, 16. All right, here's 17. All right, don't ask me why this got off. It got off a little bit. I'll fix that for next year. So let's see here, environmental practice 3. So we've got some vocabulary words to do here. So our terms, we've got matter, atom, element, nucleus, molecule, compound, hydrocarbon. So on the hydrocarbon one, just write it on the next page. That's fine. If you can make it fit there, that's fine too. Solution, protein, nucleic acid, carbohydrate, and lipid. So there's tons of vocab words. Just like last time, you can use your notes, you can use your textbook, you can use Google. I don't care what you use as long as it's not somebody else's paper to look up these definitions. So the first column right here, this definition, all right, that's what you find from one of those resources. And then you need to put how you're going to remember it. Now, I looked around the room, and some of you on this how I remember it was you wrote the same thing all the way down through here. No, that's not going to work, folks, okay? Each one has to have a different thing. It's going to be unique. How you remember the term matter is different than how you're going to remember the term atom. Now, they might be connected, but it's not going to be the exact same thing. All right? So this is not like how you plan on remembering. It's how you're going to tie matter into something that you already know. Okay, let's talk about the questions, or what we got going on here. We got a water cycle activity. So the instructions here on page 19 say to read the sentence below, find the missing words, and then write them in the empty spaces, and find the hidden words in the puzzle. So it says the sun, let's do the first one together. The sun turns the water on earth into a, what does it turn it into? Okay, you right there that's raising your hand. What did it turn it into? Did you say gas? Well, if you did, then you're completely and totally, well, I think you're right, yeah. Okay. Now, you back there that's got your hand raised, I'm sorry I didn't see your hand because I'm not really in the classroom. Okay, so now the sun turns water on the earth into a gas. Let's see if we can find the word gas down here somewhere. All right, let's see if I can find gas. Let's see, there's stream. Does anybody see gas? I'm not very good at this. Looking for G's, looking for G's, looking for... There's a G. Nope, that doesn't work. Da-da-da-da-da-da-da-da. You guys probably all found this before me, didn't you? You're probably really laughing at me too right now, but that's okay. I'm not here to listen. Okay, so I figured it out. I was wrong. Who would have guessed? Anyway, the correct word is vapor, V-A-P-O-R. So the sun turns water on the earth into a vapor, which is right here, V-A-P-O-R. Yay, I found the word vapor. Okay, quit laughing at me. Okay, so you got 7 more questions to do on your own. Find the words in here. I eventually just gave up looking for the word. Actually, I ran out of time on the other recording. So while I was waiting for it to process the video, I looked around. I couldn't find gas at all. And so I'm like, hey, wait a second. There's vapor. A vapor is a gas. And so sure enough, it fits right in there. So read these sentences, fill in words that you think you can find, or find words in here, figure out where they fit up here. Doesn't matter to me. You have the rest of the class period to work on this. You've got several vocabulary words to look up, but this is the only class time that you're going to have to do this. So I need to make sure that you stay focused all hour long. Like I said, feel free to use your phones if you want to look up these vocab words. Use the textbook, use your notes. Doesn't matter to me, whatever's more convenient for you. Make sure it's your work, not somebody else's. And then don't forget that your posters that we worked on Tuesday, Monday and Tuesday, are due whenever I get back on Tuesday. And so I will be grading those and we'll be hanging those up on Tuesday. All right, so if you have any questions, feel free to ask the sub. They've got some more information. Otherwise, I'll write them down. I'll answer them whenever I get back. So thank you again all for being good. I know that's what you're being for the sub. And I will see you in a few days. So ta-ta for now.